So in our lesson today, we're going to be looking at an introduction to complex numbers. For your essential question, I want you to answer, how do you simplify radicals that contain imaginary numbers? Now, before we get to our guided practice problems and our vocabulary, I want to take a look at these two equations and just kind of give us some context as to what we're going to be looking at with our complex numbers today. So for the first equation, we have x squared minus 9, and we're solving. So our goal is to isolate the x to get x by itself. So our first step in doing that is going to be to move the 9 to the other side of the equal sign. Well, remember, when you're solving equations, what you're going to do is use the inverse of whatever operation is currently happening. So because this 9 is being subtracted, or because this 9 is negative, we have to use the inverse or the opposite of that in order to undo that 9. So we're going to go ahead and add 9 or use a positive 9 on both sides, always to keep our equation balanced, to get that 9 away from the x. So negative 9 plus 9 is going to give us 0. So we rewrite this as x squared is equal to positive 9. So at this point, I want you to first kind of think about it as, okay, we're looking for a number that when we raise it to the second power, it's equal to 9. So we know that if we raise 3 to the second power, that's going to give us 9, because 3 times 3 gives us 9. But also, if we put a negative 3 inside of those parentheses, we know that a negative 3 times a negative 3 also gives us a positive 9. So in this case, we're actually going to get two solutions, and we can say that x is equal to negative 3 as well. Because remember, anytime you square a negative, you're multiplying a negative times itself, which will in turn give us a positive. Well, if we were going through the process of actually solving this, like I set up here with a 9, we would want to undo that exponent by using its inverse. Well, what's the inverse of squaring something? And the answer to that is square root. So if we were to square root both sides of the equal sign, again, to keep the equation balanced, what happens here is that the radical, the square root, and the square undo each other. So essentially they cross each other out, and that leaves us with x is equal to the square root of 9. But again, we know the square root of 9 is 3. But when we're solving, again, and you have that x to the second power, you're always going to get a positive and a negative 3. And so you're going to see that written as x is equal to plus or minus 3. So these are both real number solutions. Positive 3 and negative 3 are both real numbers. Over here, we have x squared plus 9 equals 0. So again, if we were to go through that exact same process to try to isolate the x, to solve for x, we would first subtract 9 on both sides. We use subtraction because it's the inverse of addition. So 9 minus 9 gives us 0, and that leaves us with x squared is equal to negative 9. Well, now here, we're looking to see, well, what number to the second power equals negative 9? Now, don't you say negative 3, because we just said over here that negative 3 to the second power is equal to a positive 9, because that's negative 3 times negative 3. So over here, there is not a real number solution that when we raise it to the second power is going to give us a negative number, because two positives are going to give us a positive and two negatives will also give us a positive. Now, what I want you to do is, if we were to use the same method where we use the radical to undo this, if you were to type the square root of negative 9 into your calculator, it's going to give you an error message. Because again, this is not a real number solution. This is what we call an imaginary solution. Now, it's not an imaginary thing. It's not something that I just made up. And really, it's bad that they call it imaginary, because it does exist. It is an actual thing. There is something called the imaginary number plane, which we are not going to get into in this class, but this is something that does exist. And that's what we're going to be looking at today. Given that we've been talking about radicals in this unit, we're now going to look at taking the square root of a negative number to get those imaginary answers. Imaginary number answers, I should say. Now, first, let's take a look at a couple of things that actually use imaginary numbers. So you guys know that I'm not making this up. So this here is something that maybe some of you guys have seen. This is probably something more from my generation. But when you have music playing, you guys can see that as the music comes out, the spectrum analyzer will go up and down depending on the music. And this is something that does use imaginary numbers to calculate. Electricity is also another thing that uses imaginary numbers in its currents. So let's take a look at vocab now. Our first vocabulary term is real number. A real number is all positive and negative integers, fractions, decimals, and irrational numbers. Now, irrational numbers are those leftovers that we see inside the radicals, the numbers that if you type into the calculator, they have this big long decimal answer. Basically, any number that you guys have dealt with up until this point are considered real numbers. So then that brings me to imaginary number. And the imaginary number is what we just saw in the previous slide, where we have that negative number under the radical. Well, when we have that negative number under the radical, we are going to replace that negative with the imaginary unit I. So our imaginary number is the number I. It's a complex number that can be written as a real number multiplied by the imaginary unit I. So it could be 2 times I, or 3 times I, or negative 5 times I, where the coefficient is the real number and the I is the imaginary unit. A complex number goes right along with the imaginary numbers, and with our complex numbers, we will write it as the sum or difference of a real number and the imaginary unit. So this is a number that can be written in the form A plus BI, where A is the real number part of the complex number and the BI is the imaginary number part of the complex number. Now, something to take note of is that I is equal to the square root of negative 1. So whenever we have that negative that's under the radical, again, we will replace that with the imaginary unit I. And so we will then remove that negative from the radical and replace it outside the radical with the number I. Now, the next thing I want you to think about is, well, what would happen if we squared I to the second power? Well, if I is equal to the square root of negative 1, then I squared is going to be the square root of negative 1 times the square root of negative 1, because that is what squared means. You multiply a number times itself. So I is equal to the square root of negative 1, and then we multiply it times itself, so we square it, so we multiply that times the square root of negative 1 as well. Well, we've seen this just last week. What happens whenever you multiply a radical times itself is the radical goes away. And so the square root of negative 1 times the square root of negative 1 is going to give us negative 1. Well, if we apply the same idea that we just saw in the previous slide, if we square negative 1, well, the radical and the exponent undo each other because they are inverse operations. And again, that leaves us with negative 1. So you can look at this either way, but in both cases, I squared is equal to negative 1. So if and when we are simplifying imaginary numbers, anytime we see an I squared, we will replace that with negative 1. So let's take a look at some guided practice problems now. So for simplifying complex numbers, for this one, we're going to simplify the following radicals. And we know that we cannot take the square root of a negative number because it is not a real number. But what we can do is simplify this and find its imaginary part. So we have the square root of negative. It's a little wacky. Let me undo that. We have here the square root of negative 144. So what we're going to do here to simplify this is break it up into the imaginary part and the real number part. So we can break this apart and we can say, okay, we know that the negative is a negative 1 times 144. And now we have this imaginary piece here as well as the real number piece here. So we can go ahead and we can simplify this within each piece. So referring back to the vocabulary, we know that the square root of negative 1 is I, and the square root of 144, now if you don't have that memorized off the top of your head, you can refer to your multiplication chart, or you can cake it. In either case, you're going to end up with 12. The square root of 144 is 12. Now, whenever you have I as part of your answer, it's always going to appear directly after the whole number coefficient. So the answer here is simply going to be 12I. Now, I will always put a curl on my I just so it doesn't get mixed up with ones. I encourage you guys to do the same thing. For this one, again, our answer is 12I. Now, this is the case when the real number part is a perfect square. We have no leftovers left inside the radical, and so we simply have the real number part 12 and the imaginary part I. Well, let's take a look when we do have leftovers. So for part B, we have the square root of negative 124. So again, we break this apart into the imaginary part times the real number part, We know that the square root of negative 1, again, is I. And what we're going to do here, because 124 is not a perfect square, is we're going to go ahead and we're going to cake 124. So if I divide by 2, that leaves us with 62. Divided by 2 gives us 31. 31 is actually a prime number, so that's going to be simply 31 and 1. So I have a pair of 2's and a leftover 31. So this will be I times 2 radical 31. Now again, as I just said with A, the I is going to come right after the whole number real part. So in this case, it's going to come directly after the 2. So we're just going to go ahead and flip this order around, and our final answer is going to be 2I radical 31. So our leftovers still go back inside the fridge or the radical. One of the pairs will go outside the radical, and the I is going to go between them. So the I comes again directly after that whole number coefficient. All right, let's go ahead and take a look at one more. Here we have 5 times the square root of negative 192. That 5 is going to come into play at the very end. That's a coefficient we're going to multiply by whatever pairs we get. Let's go ahead and separate this into the imaginary part, negative 1, square root of negative 1, times the square root of 192, our real number part. Again, we know that the square root of negative 1 is I, and 192 is not a perfect square, so we can go ahead and we can simplify that using the cake method. Starting out with 2. 2 goes into 192 96 times. Divide that by 2. That gives us 48. Divided by 2 gives us 24. Divided by 2 gives us 12. Divided by 2 gives us 6. And divided by 2 gives us 3. And 3 and 1. So we have 3 pairs of 2's and a leftover 3. So 2 times 2 is 4, times 2 gives us 8. Radical leftover is 3. That I is going to come between the 8 and the rad 3, though. So we have 8I radical 3. And lastly, we want to take that coefficient from the very beginning, place that out front, and we will multiply these real number parts. So 5 times 8 is going to give us 40I radical 3 as our final answer. All right, for GP number 2, we are now multiplying complex numbers. Now, this is extremely similar to multiplying polynomials like we did last semester, where we will double distribute here. The only difference is we're going to have that I that's involved. So let's go ahead and take a look and see what that looks like. I do want to remind you that each guided practice problem does need to have toolbox items. So we do need to make sure that GP number 1 all of the simplifying the negative radicals, has its own toolbox item directly next to GP number 1, and that GP number 2 has its own toolbox items directly next to it in your notes. So for this one, we're multiplying two binomials here. So we are going to go ahead and break apart the first binomial and distribute each piece to the second binomial, again, just like we did last semester. So break apart that first binomial, that's going to give us 4. Multiply it to the second binomial, so times 8 plus 2i minus 5i times 8 plus 2i. We're going to go ahead and distribute here. So 4 times 8 is going to give us 32. 4 times 2i is going to give us 8i. Distribute the negative 5i. I'm going to go ahead and stack my like terms. So negative 5i times 8 is going to give us negative 40i. And negative 5i times positive 2i is going to give us negative 10. And then I times I is going to give us I squared. Now at this point, we can go ahead and we can combine our like terms. So this is 32. 8i minus 40i is going to give us negative 32i. And then here we have negative 10i squared. Now this is not simplified. Again, remember what I said in the vocabulary is anytime we have an I squared, we are going to replace that with a negative 1. So this is going to be, so right now this currently reads negative 10 times I squared. So if we replace the I squared with a negative 1, we now have negative 10 times a negative 1, which gives us plus 10, which is a constant. So here we have our imaginary numbers. Here we have another constant. So now we're going to take that 10 and combine it with the other constant. So we're going to add that 10 to the 32. So when we finally simplify, we're going to have 42 minus 32i. That is our final answer. Again, you always want to write your complex numbers in the form a plus bi. So that imaginary part should always come after the real number part. So that imaginary part should always come second. Again, remember that I squared is equal to negative 1. And it is not considered simplified if you leave I squared as part of your answer. So that must always be simplified. Let's take a look at another one. So we have 3 minus 4i times 7 minus I. So there's an invisible one in front of that I. So we're going to break apart this first binomial. We have 3, and then we have negative 4i. So we're going to have 3 times the second binomial, 7 minus I, minus 4i times 7 minus I. So we will distribute first the 3. 3 times 7 gives us 21. 3 times negative I is negative 3i. Negative 4i times 7 is negative 28i. And negative 4i times negative I, negative times negative is a positive 4. And again, I times I is I squared. So this, again, is going to be a 4 times a negative 1 because that I squared equals negative 1, thus giving us a negative 4. So I'm going to stack that with my constant now and cross this out because now I've used it. So from here now I can go through and combine my like terms. 21 minus 4 is 17. And negative 3i minus 28i is going to give us negative 31i. So here our final answer is 17 minus 31i. Again, make sure your answer is in the form a plus bi. Again, where the first is your real number and the second is your imaginary number answer. Don't forget to answer your essential question.